almost like it's four functions. There's there, it's there, it's there, and it's there. Do you see?
Yes.
Yeah.
So I really don't think that you will be. In fact, I mean, do they expect you to answer
Wait,
this?
then it's fine. You can skip it. It's fine.
But we can say, I mean, we can. So the thing is, like, do you see it stops? Do you see it stops here? Do you see it stops here, right?
Yeah.
Doesn't go on. There's no arrow. So therefore, the domain is restricted. Do you see that? Do you see that? The domain is from
-4.
-4 to
Infinity.
not infinity
3 to 4
to
to 4
4.
-4 to 4.
To 4. Yeah.
Yeah.
And then would the range be -3 to 3?
Yes. Yes. Yeah. And then, yeah, but is the, yeah, so the y values. Is W a function?
No.
No.
Why do you say it's not a function?
It is a function.
It is a function.
I thought it
It
is.
is.
Yeah.
It is. Because for every x is
Yeah,
corresponding.
fair.
Yeah.
It is a function because for every y value there's one x value. Corresponding
Let
x
me-
value is one y value.
This is actually the formal definition of a function. Or the continuous, actually. F of a, yeah, it exists. Can you hear me? Yeah, can you hear me? Yeah, so this, I would actually say this is a function because I was just concerned about this. Could you see it's very rough here? It's very rough. You guys see it's very rough here.
Yeah.
So it's not like it's a parabola. In fact, let's do this at the end because I think I wanna show you some extra stuff with it's AP Math stuff that will help with this question. But let's do it at the end rather. Okay, so let's do the next one. Which one was it now? Okay. Amaro, which one are we doing? This one.
Yes.
Okay, if sign is it 5.1?
5.2.
Okay, fine with 5.1.
Okay.
Okay. So what did you do for 5.2?
So first I arranged it. So I mean like reduced it.
Okay,
What
so how
was
did you
it?
reduce it?
So
What
I
did you
was
reduce first?
Hmm?
What did you reduce first?
the 10.
Yeah. So what did you reduce 10 to?
So
Tomorrow.
can you hear me?
Yes. Yes, I can hear you. What did you reduce 10? How did you reduce 10 of 180 plus x?
Okay. So firstly I started and I said that 10 is so 180. So I said it's just 10 of x because it's in the third quadrant.
Yeah. So what are the three steps we said? What are the 3 steps we said for reductions?
Find the
Quadrant.
quadrant.
Quadrant and
Okay. So which quadrant is 180 plus x?
The third one.
And is tan positive or negative in the third one?
Positive.
And it's 180, so it stays as tan of x.
Yes.
Okay. Cos 180 plus x. Use the same rule.
Yeah, so it's negative cos of x.
So I'm going to put the negative there. Okay. Times cos of x over 2. Am I wrong?
Yeah.
Yeah, so can you simplify tan x times cos x?
Can we make that sine 2a the one with the x over 2?
Sine x, you mean?
Yes.
But before that, what about this tan x times cos x?
Can you make that into sine x?
So cos.
Yes, because isn't tan sine over cos?
Oh, wouldn't it become sine squared x? Because if you say a negative 2 sine x over 2 times cos x over 2, it become cos 2 x over 2. So you'd have sine x, and then you'd get then you'd multiply it by that, and you'd have sine x. You'd have sine squared x on the top.
Okay, just all
I didn't understand.
What?
spur of the moment there. Okay, but let's just go let's just write there sine x. We take it one at a time. So okay, what is tan of 360 minus x? That's a good idea, Iman. It's a good idea.
Tan of x.
It is the yeah. Tan what? Negative tan x.
Yes.
Okay, and then tan of 90 minus x. Apply the rule. Who wants to do tan of 90 minus x for us? Come, guys. Rivka, you gonna do it?
What?
Rivka, you gonna do the tan 90 minus x?
Okay.
It's 1 over 10x.
Okay, but now follow the steps.
It's
Quadrant.
in the first quadrant,
Mm,
and then 10 is positive in the first quadrant.
yes.
It's 90 minus x, so
Mm.
it will become 1 over 10x.
1 over 10x. What do you think can happen there?
Can you repeat that again, please?
Okay, so tan 90 minus x. Now, if you say it's in the first quadrant.
Yes, it's in the first
Tan
quadrant.
is positive or negative in the first quadrant?
Positive.
Positive. And if because it's 90, it changes to the co-ratio. So from tan, it becomes cotan.
I'm confused as to why tan 90 minus x isn't just equal to tan x.
Yeah.
Because it's of the 90. So we said the rule is 90. It changes to the co-ratio. If it's 180, it stays the same.
So all we need to know is that the co-ratio would be 1 over 10x.
Yes, it's cotan, but cotan is just 1 over 10.
We actually didn't learn this at school. I just have
Yeah.
it in my memory because you taught that to me. That's why I remember that.
Okay, so it's okay if you were not taught this at school, because there's a concept video on an approach to reduction. We explain this in great detail. In fact, let me just teach you something just to make you very happy. What is the co-ratio of sine?
Cosine.
Why do you think it's called cos?
Because it's 1 over sine. Oh, and then that's why
Is
90
the-
minus x is equal to sine.
No, look here.
Wow.
We call it sine and cos, but it's actually, if you fill it out, it's sine and cosine. because cosine is the co-ratio of sine. Just like
Oh,
cotan is the co-ratio of tan.
Co.
Oh,
wow.
I didn't teach you this.
no.
Okay.
No.
So this is the understanding, you see? This is the understanding part of the math syllabus that I think
But-
is very much neglected by the syllabus. Okay, so let's go on.
Okay,
Sine
yeah.
x. Are you happy? Are you guys happy with 1 over tan x, cotan x?
Can I just ask something?
Yes.
Say, for example, we didn't know this, and now we're writing, and we just say tan x or negative tan x. So, would that be wrong?
Yes, because tan x is different to 1 over tan x.
Okay.
So that's why you must follow this rule. Because if you follow this rule, you'll never go wrong. Never go wrong. You see, that's why you must know these. That's why I prefer follow the steps carefully. Okay. And there's even a quiz on this. There's a quiz on trig reduction. And I deliberately put tan 90 minus x in the quiz so that you guys can get practice with that. But yeah, just in case cosine, because cos is the co-ratio of sine. Okay. But they don't say it like that. You say sine and cos, but then people might miss the connection. But that's where it comes from. Okay, so and you've got so do you agree these will cancel here?
Yeah, bro.
And then you've got sine x there. Right. Do you guys see that?
Yeah.
Yeah.
That
Yes,
cancels.
yes.
Right. And these negatives can cancel, right?
Yeah.
Now, Iman, tell us your idea.
I said that because 2 sine x over 2 times cos x over 2 is equal to sine 2 theta in this case, which would be x over 2, and then the two twos cancel, so you're left with sine x, and then that would that's
That's it.
Okay. Elias, I got the where does the negative in front of this 2 come from before we get to that 50 part?
Because cos 180 plus x is negative cos x. So I just put the
Oh.
negative there just to make it easier for ourselves.
I see, I see.
I always put the especially when you're multiplying things, always put the sign at the beginning. It just makes your life easier. Okay. So this was a nice question. But question, guys, was there any new maths here?
Can you explain what Iman said? Because I did not follow.
Oh, okay.
Yeah, I also
Okay.
didn't get it.
I'm
Okay.
sorry.
Okay. So sine 2x equals
Compound angle.
The ratio.
but if I replace this 2x with x, then that's just going to be half. Which is what we have here.
Oh,
Um,
that makes sense.
Okay. So yeah, so that's quite a cool. So this whole thing, this horrible thing is just sine of x. Yeah. Okay, let's go to the next one. Tomorrow, gonna do your one. Okay, 5.3 or 5.4? Which one you want to do?
Can we do
Tomorrow?
both ones?
Okay. So what was your approach for 5.3? Mara?
Yes.
What did you do?
We first could we divide both by cos so that we can have the same ratio.
That's possible. Yeah.
I think can we change the cos 2 theta
Oh, sure.
to the compound angle?
Which compound angle? There's three.
Double angle. Yeah, a compound angle. Yeah, sorry. The
So
sine one, sine squared one.
remember I told you guys, when you have cos and sine, always do the sine first, because that's only one. Right? Do you guys agree?
Yeah.
There's no other one. There's no other
Yeah.
one for sine. So if we change that to 3 cos 2 theta minus 2 sine theta cos theta minus 1 equals 0.
I was thinking that maybe with the double angle we could do the quadratic equation, but I think this will work also.
It is a quadratic equation, but which one? What did I say in the past live session when it comes to this? This is the giveaway. What did I say?
Didn't you say we must replace it with A and B, something like that?
Yes, but so what type of equation do we want to create here?
A quadratic equation.
What type of quadratic equation?
With two variables.
With two variables. So because x squared plus 2xy, do you guys remember this?
Yep.
For me, 2xy is that. Do you guys see that?
Oh yeah.
Now tell me something about this equation. Are there any constants?
No.
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 So that automatically tells me something. It tells me that I must change this minus 1 into sine squared plus cos squared. And it tells me that I must change the cos 2 theta into cos squared minus sine squared theta. Because, do you guys agree there are 3 different possibilities for cos? Guys?
Yes.
Yes.
Yeah.
This one, there is no constant. This one, there is a constant. And this one, there is a constant. Do you see?
Yeah.
Yes.
Yes.
Because the goal is to create something like this. And to do this, there must be no constant. So I'm going to change it to cos squared minus sine squared. So do you see why doing the sine first gives it away, as opposed to doing the cos? That's why I always leave cos for last, because there's 3 possibilities. Okay? Let me know if I'm not making sense.
I have a question.
Sure.
I'm not sure if you're allowed to do this. But could you have changed the cos to theta into, say, for example, 1 minus 2 sine squared, and then said that the entire quadratic equation is equal to 1, and then made all of your answers like equal to 1 and solve it like that? Or does it only work if you have a 0 on the other side of the equation?
It only works for 0. So it's called the
Okay.
0 product rule. Because if you have an expression AB equals 1, then that's infinite amount of answers. But if you tell me that AB equals 0, oh wait, okay, let's do it like this.
Okay, no, I understand.
Yeah, okay.
Thank you.
So only if it equals 0. So let's apply what we've said. So let's change the cos 2 theta into cos squared minus sine squared. So it's 3 cos squared minus sine squared, right? Minus 2 sine theta cos theta minus, now the 1 is just what? Sine squared plus cos squared. But if you say minus, then it's minus sine squared minus cos squared. Do you guys see that? Guys?
Yeah.
Yes.
Equals 0. We simplify 3 cos squared. Maybe at this stage, okay, yeah, let's just do it like that. So what's the simplification going to be?
Two cos squared minus 2 sine theta cos theta minus 2 sine.
2 cos, yes, we're getting there. 2 cos squared minus 2 sine theta cos theta, right? Minus 4, sorry, minus 4. Iman? Are you guys following?
Yes.
No.
Never mind.
What? Somebody said no.
Amara said no.
Amara, which part is not clear? Amara,
The last thing you did, can you redo that, please?
which thing?
3 cos squared theta minus 3 sine squared theta minus 2 sine. The blue one, the first blue line.
I'm just simplifying that.
Yeah. But then, what did you do to get to the next blue line? Can you redo that?
3 cos squared minus cos squared. Minus 3
Oh.
minus, yeah, I just added like terms. And then what can we do now?
Factorize.
Something first before we factorize. It's some easy step that we could do.
Divide by
Divide. Divided by 2, yeah, to make our lives easier. Cos squared minus 2, sorry, minus sine theta cos theta minus 2 sine squared theta equals 0. Now, how do we simplify this? Remember I told you guys, we can replace this with x and y. So make x cos and y sine, just to make it easier. So it becomes x squared minus xy minus 2y squared equals 0. Anybody want to try factorizing this? Nafisa? Iman?
Would it be cos minus 2 cos minus sine 2 and then would be cos plus
Okay,
sine
but
1?
do the variables based on this
Oh,
one.
sorry, sorry, I didn't see that. It would be x minus 2 and then 2y and then x plus y.
X squared minus plus xy minus 2xy, which is minus xy minus 2y squared. Do you guys see that? Guys?
Yes.
Yeah.
Do you find the factorization difficult?
Elias, you can actually use synthetic division for that type of question also. I figured.
But it's not a cubic. Or
But
you
it
mean like,
works for a quadratic
okay,
equation, it works also. And I was like, wow.
is it
Welcome.
faster?
Hey, Nafisa.
What?
Elias,
Yes.
can you explain synthetic division, please? Because Nafisa keeps using that word and makes me want to cry because I don't know what she's talking about. And she doesn't want to explain it to me.
Have you watched the
It's like the
concept
best
video?
thing in life.
It's like literally the easiest thing ever.
Have you watched this video,
Exactly.
Iman?
No, I didn't know there was a video.
Okay, so
You
I'll-
told her about it last night, and then
You did not tell me, don't lie.
okay,
Okay,
Amara.
okay,
But we told you what it was, eh?
okay, children, just calm down.
Leanne, that's your
Iman,
cue.
Iman,
Yes.
how to find the x-intercept of a cubic function.
Okay.
I go
I'll
through
watch
it in
that.
a lot
Thank
of.
you.
Okay.
But it's like after the first type. There's like 2 types in one video. See much was the second part. Yeah.
Yes, I prefer the first way, but Nafisa likes the other way. But anyway, so okay, so let's complete this. What's the answer? X equals 2y. X equals.
Negative one.
Negative 1.
So therefore, if we replace it now, x was cos, so cos equals 2 sine, and cos equals minus sine. What do we do now? What did we say, guys? We've done a similar question like this before.
You divide it by sine on both sides.
Not sine.
Cos.
Cause
Yeah.
Why? What will that do?
It will make
give us
10.
one ratio.
It will
The
give us
same.
10. It will give us 10, right? So it'll become 1 equals 2 10. If you divide by cos, so then 1 equals minus 10. And then we can just simplify, and that becomes divide by the 2. So 10 equals a half. Or 10 equals minus 1. Do you guys see this?
Mm-hmm.
So we're done now. So now we have to type it in the calculator. What do you guys get? Do they want the general solution?
So the
Generals.
reference angle is 26.5.
0.557. 56.
26 comma 56.
6.
Are we done?
No.
Plus k into 180. K is an element of Z.
We done?
Nope.
Then we do. What's the reference angle for tan of minus 1?
It's
Minus
negative 45.
No, remember we take for the reference angle, you just take the, yeah, you take the positive of this. So it's tan octan of 1, which is 45. But then what do we say?
In the second and fourth quadrant, tan is negative.
Yes, but remember, we don't worry so much about the fourth quadrant because of tan, right? So what's the answer going to be? Theta equals
180 minus
35. Oh, 180 minus
35
35.
plus k,
which is 135.
135.
Okay, so that's that answer. This was a long one, but do you guys see how it all started from this? Recognizing that you had that 2xy. So then I thought of this. Do you see, guys? Okay, so when you see it, so I mean, this is a thinking process. You see, this is not on the memo. This is a thinking process that when you see questions like this, you're thinking of things like this. And that's all really maths is. It's about being able to identify patterns and to identify approaches for particular questions. Okay, so let's go to the next one, the identity. Okay, prove the identity. What did you try here, Amaru?
So what I did first was the right hand side. So, but then I got lost. But yeah. So it's signed the right hand side first.
Yeah, so what did you get? Did you just do the right hand side, do the left hand side also?
So while I was trying it, I got lost, so I wasn't sure.
So where did you get lost?
When I first pulled it out, right? So
What did you?
what? What did you say?
What did you try when you worked through this question?
Okay, so what I did first was I took the right hand side and I folded it out.
Okay, so what did you get when you
So
filled it out?
sine squared x
Plus?
plus 2 sine x cos x plus cos squared x.
Good. Which, if you simplify this, can become?
So in the middle, that becomes sine of 2x.
Yeah. And the sine x squared plus cos x squared?
Plus 1.
Oh, 1.
Okay. I'm not so convinced though. So let's just keep this here though. But let's work on the left hand side and see what we can get there. Okay. So okay. So let's try the left hand side. What did you do on the left hand side?
I didn't know what to do.
Okay. So anybody want to give her some ideas? Was there any ideas?
Nope.
Think of the concepts you've been taught in trigonometry in grade 12. Which ones do you think can apply?
Could the
The
expanding
compound. Yeah.
Yes. So
Mm.
remember, guys.
Um,
Yes. Yes.
if you expand it to cos for, oh wait, never mind. Because I was gonna say if you it's like you, I can't remember what it's called. That for when you said cos 45 times sine sine x, and I mean cos x, and then it would be over 2, and then you could have cancelled out with the 2, but I'm not sure how it would work with there being cos squared instead of normal cos.
I have an idea. What? I'm not sure if this is gonna work, but let's just see here. 2 cos squared. This is what we have at the moment, right?
Yes.
Equals that. Do you guys agree?
Yes.
Let's take the 1 over.
But how can we do that though?
Because it's equal to each other.
Yeah.
And then
Yeah,
But
it's
it's not.
equal to-
Well, it's
we
actually
must-
it's an identity. Sorry, it's an identity. We can't do that. Sorry, you're
Oh.
right. You're right. You're right. You can't do that. We can do the compound angle rule.
Can you still
Elias,
do
can
that
you
if
do the
your
compound?
thing is squared?
Mm.
Would you just, how would it work?
It would just be squared at the end.
Oh, okay, never mind.
So I mean, so you just so it's gonna
Oh,
be
but-
2 in yes.
But then it would work, because then you'd be, if you converted your cos 45 into like root 2 over 2, then the it would cancel with the 2 over there, because everything would be over 2 then, and then your squared thingy would be.
Okay, let's write. We write it down, then we see it. I think it's better.
Okay.
We write it down. So what is cos 45 minus x? Expanded. Iman?
Cos squared 45 times cos squared x plus sine squared 45 sine x.
Let's leave the squared out. Let's first do cos 45 minus 6 and then squared afterwards, just to make it easier. Because do you agree that this squared is only it's this squared, so you can work out this and then square it. Do you see?
Yeah.
Okay, so what is cos 45 minus x expanded?
cos 45 cos x plus sin 45 sin
Five.
x.
Yeah,
And then we
squared.
use
Okay. So cos 45 can be changed to?
Root
Iman,
2
you
over
said?
2.
And sine 45?
Also squared with 2.
yeah.
And now what do you think we can do?
Them all over 2. So you'll have root 2 cos x plus root 2 sine x over 2.
Okay, that's a good idea. Root 2 cos x time plus root 2 cos x over 2. Now what we going to do now?
Do we
Sine x, sorry. No, wait, sorry. It's cos x root 2. Yeah, sorry, it is right, yeah.
do
Guys,
we binomial now?
can you hear me?
Oh,
Yeah.
wait.
Yeah.
Sorry.
Yes, Iman, any ideas?
But I wouldn't have, if you had left the side, the square in, then you could have said, then that the root 2 would have fallen away, and then, okay, because then you could have said, you could have taken that numerator that you would have ended up with, and then you could have taken it out, and you would have had cos squared plus sine squared, and you could have turned that into 1. I think.
Mm. So
Oh no,
we,
no.
we still need to square this.
Never mind.
Yeah.
So let us square it. Okay. So we have to, let's take the 2, keep the 2 there. Do you agree if I say a over b squared, that is just a to the b, no, sorry, a over b squared, that's just a squared over b squared. Do you agree?
Yeah.
You can, so therefore we can just change this to 2 squared at the bottom, which is 4. And then just worry about squaring this, do you see?
Yeah.
So now it becomes easier because then the 2 over here can cancel with that.
Mm.
So it becomes, remove that, and then you remove that. So then you're left with that. Okay, so we are getting somewhere. We are getting somewhere. Now we must square it. Who wants to square this for me? You can, do you want to do the FOIL method first? Write out both.
Yeah.
So this isn't an easy question, but yeah. Root 2 cos x plus root 2 sine x.
So it's 4.
No, it won't be 4 because the root will cancel, isn't?
2, sorry, 2. Yeah, because it cancels, so it's 2.
I'm confused
What's
as
root
to
2?
why. Did you
Because
write
it's-
the thingy down twice because it's squared?
Yes,
Yes, we're just following it out.
Thank
just to
you.
make it easier to do it. What's root 2 cos x times root 2?
2
Isn't
cos
it 2
x squared.
Isn't it?
Yeah.
2 cos squared.
And
And
then
then 2
plus
sine f cos x plus
2 sine squared.
It's going to be times 2, so it's going to be 4.
Oh,
Why would it be 4? Because won't the
Oh,
yeah.
okay.
yes.
No.
So it's
Oh,
outer
okay.
That times that, yeah, sorry. So 4 cos, yes, squared.
plus
Yeah. Plus 2 sine squared x.
over
2. Now.
what can we do now? What can we do now?
Can't
Factorize
we divide everything by 2?
Yes. So what does that become?
Cos
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 x
x,
plus
yeah. 2
2
sine x
sine
cos
x
x.
Sine cos
sine
x plus
squared
sine x.
x.
Then cos squared x plus sine squared x is 1.
1. And then we get the same. Oh,
Oh, wow, yes.
wow. I would have
Don't
never
say
got
wow. The thing is, guys, have we done any new maths here?
No.
We haven't done any new maths. We haven't invented anything new. All we've done is that we've done our compound angles, and you have to know your algebra. Do you guys see that?
Hmm.
You have to know your algebra. Now, of course, do you guys know there's no algebra in grade 12? There's no algebra. However, you've done a lot of algebra up till grade 12. You see, this is the algebra mind map, but there's nothing in grade 12. But you guys have to know this stuff, factorizing. You have to know exponential equations, simplification, which is what we've done here, right? Simplification, which is grade 10. So you guys see, it's a cumulative thing. Do you guys see that?
Yeah.
Okay, so that's why you have to go watch these videos. Okay, so now, okay, we're not done yet. What's the maximum value of sine x plus cos x? What's the maximum value of sine x plus cos x? So they say hence. That's interesting, hence. What do you guys say? What do you guys think?
So it's related to what you just did.
So they say hence determine the maximum value.
Would it help if you took that expanded form of the identity and then you factorized it and then found like what you got, like put it in the form of x plus whatever and then bracket x plus whatever and then did something to that effect? Would that help?
So here's your sine x plus cos x. Where's the others? Zaid and Ayan. See there. Sine x plus cos x, and here's sine x plus cos x squared. Do you guys see that?
Yeah.
So how can you solve for sine x plus cos x?
It's 1.
What can you do?
It's 1. It's equal to 1.
No, that's sine squared x plus cos squared x.
Oh, okay. Sorry.
Using this equation, how can you solve for sine x plus cos x?
Make it equal to 0.
But
I'm so
then,
confused.
Why is sine x plus cos x equal to 0?
because you want to solve for sine x and cos x. And
Find an expression for sine x plus cos x using this. What do you guys think, Naima? Naima, any ideas? Iman?
Are we making something the subject of the formula or something?
Yes, so we want to find sine x plus cos x, so that's what must be the subject of the
Isn't
formula.
it when they ask
So
for
it
the
will equal
maximum value, you make the equation equal to 0? Is that not the
You make the derivative equal to
No
0,
derivative.
Oh yeah,
but
sorry.
you guys haven't done derivatives for trig functions yet.
cos x plus sine x will equal to negative 2 sine x cos.
Why do you say that?
If we make it the subject of the formula. Well, I think I'm wrong. Just to
You
ignore
use
me.
this formula. They say hence, right? What does hence mean, guys?
You must use it
Use
to
the
the
truth.
information you were given previously.
So using this equation, how can we find an expression for sine x plus cos x?
Oh, it will equal to that 2 cos squared 45 minus x minus 2 sine x cos x.
No.
No.
Oh, wait, would you? Okay, no. Are they?
No.
That's basically the square root of that. So would you find that
Yes.
square root
Yes.
there?
Yes. Yes. What if you square root this, guys? Then that leaves you with that.
Sine. Oh.
Okay. So good job. So you've got this. So you've got sine x plus cos x equals the square root of 2 cos squared 45 minus x. Now you have to know your algebra for this one. How can you simplify this? What is,
So
yeah,
root
Can't you do the
root
square
2 times
the-
cos 45 minus x.
say it again, Iman, say it again.
Root 2 into cos
Yes.
cos 45 minus x.
Yes, because if you've got root of a times b, that's the same as root a times root b. Okay. Does that make sense, guys?
Yes.
Now, we've simplified it. Do you guys know the graph cos 45 minus x? How does that look?
Squashed and shifted.
Not squashed.
What?
Mm-mm. Remember, if it no.
Oh, I see, I see, I see, I see.
What do you see?
It wouldn't be squashed because there's no change to the period.
So what is the change for this graph?
It's shifted and the amplitude changed.
Yes. Now, Iman, you basically there. Hence, determine the maximum value.
Oh, and then you basically, because you know that if you take this and then you put it like into like a into a form where cos is alone and sine is alone, whatever. Oh no, never mind. Now I'm lost again. No, it would be root 2 because cos 45 minus x is equal to 1 because they're asking for the maximum value of it. So basically, you're finding the maximum value of the graph. So cos 45 minus x we know would be equal to 1. Therefore, 1 times
no,
root 2
wait,
is
wait,
equal to
wait.
root 2.
Cos 45
No?
minus it's not equal to 1. Cos 45
No?
minus x.
Okay.
Well, what is this graph look? This is not a this is a graph that looks like this. Let's draw the graph. How does the cos graph look? How does it start off? Guys, you must memorize the graphs and how they look, okay?
The cos graph starts at 1, isn't?
It starts at
Yeah.
1, right?
Yeah.
And then it does that. Okay. But what about the graph of 45 minus x?
It's shifted 45 upwards, is it?
Mm-mm.
No.
Let's go to Desmos, our old friend.
To the side
I'm looking
horizontally.
at it right now.
I'm confused. Oh, would it be sorry 45 leftwards? I mean.
Nafisa, what you use?
Oh, I just said I'm using Desmos to see the graph also. Yeah. I like that website. But
Yeah,
but that website doesn't allow it. I don't know where to put the fractions. Can't find the
You
fractions.
could just say
Say
divided.
divide.
Say divided. It will create the
Oh,
fraction for you.
okay.
Look at this graph. Do you see? It's just the graph of cos x, but it's just shifted to the right. Do you guys see that?
Mm-hmm.
Sorry, let's just make this look nice. It's actually, yeah, do you see it's kind of shifted to the right to 45 degrees?
Yeah.
But my question, are they asking for the maximum value of this graph? Right? When you change P, does that change the maximum value?
No. So it
No,
will
you're
still
just
be
shifting it.
1.
So it doesn't matter. Yes, 1 is the maximum
Oh.
value, but that's not your function. Your function is root 2 times that.
Root 2. So
So what's the maximum value?
1 over root 2.
Not 1 over, no.
I don't know.
Okay, so the concept video on cosine, the amplitude of a graph is this.
yes, so the maximum value will be root 2.
Yes, and that's your answer.
Yeah.
Oh.
Hence determine the maximum value of that. But that is just what we have over here. So do you guys see, when were you taught about cos? When were you taught about cos?
Grade 10.
Okay. So you would only be able to understand this if you knew this. And of course, in grade 11, you are taught things like this. Sorry, where is it? Grade 11, the shift of, yeah, the effect of P on trigonometric functions. Do you see that there? Okay, that was grade 11 work. So 45 minus x just shifts the graph to the right, doesn't change the amplitude. So I want you guys to go through these concept videos. I can't emphasize it enough. I feel like I overemphasize it, but I can't emphasize it enough. Okay, next question. Are you happy? Mara? Okay.
yes.
3D trig. In the diagram, okay, so what did I teach you guys about 90-degree triangles and stuff like that with 3D trig graphs?
You should use the trig ratios
Yeah.
for right angle.
Now that reminds me, I must tell you a story at the end, like last week.
Okay.
But it's not as sad as last week. But
it's like, yeah.
okay, so in the diagram, the observation points A, B, and C lie in the same horizontal plane. So A, B, and C is horizontal plane. Do you guys see that? A, B, and C is horizontal plane.
Yes.
Yeah.
Yeah.
And P is vertically above, so it's 90 degrees. So this is a 90-degree triangle. Do you agree?
Yeah.
Is this a 90-degree triangle, ACB?
No, it's not.
You don't. Yeah, you don't know because you don't know about that angle. Because you're right, you don't. It's not. You can't assume. The angle of elevation from P is theta. So you guys can see there, theta. That's that triangle. Okay. And then ABC is 90 minus alpha. The distance from B to C, where's B to C? B to C is half the distance from B to A. So what does that mean for BC's length?
BC is equal to 2
Twice.
here.
Yeah, but in terms of D.
2D.
No.
Oh,
BC is half. So what's it going to be, guys?
a half
D.
D.
Hmm. Okay.
Mhm.
So Amaro, what did you try with this question?
So when I tried doing this now, I couldn't get in 6.1 when they said show that H is equal to that.
What did you try?
What?
So what did you try to do? Like, what was your approach? Like when you looked at the question, what did you try to do?
Okay, to be honest, reading the question I didn't understand properly because it said the observation points A, B, and C, and that's like the first time I've seen a question Trig function saying that. So that made me a little bit
But it says there it's horizontal plane. So we've done questions like that before, right?
yeah, and then they were
So
like when situation, so like yeah.
because I want you guys in the future to try. I want you guys to struggle with the questions, and I don't mean it in a bad way. I don't mean it in a bad way because I say, you know, maths is a struggle, but I want you guys to struggle now rather than to struggle in the exam. Because I don't want you to struggle in the exam. That's why I say make the mistakes now, don't make them in the exam. Do you see the two triangles? So I really want you
yeah.
guys to grapple with these questions before you send them. So does anybody want to give an approach to the question?
I think
Naima?
maybe we find the length of AC.
Yes. So what is the question want you to find H?
Yeah.
Okay, so you want to find AC. Why do you want to find AC?
Because I think that to find H, we're gonna use opposite over adjacent, and AC is the adjacent.
Yes. So just write out the equation for me formally. So so you're gonna say which ratio is opposite of adjacent?
10.
10.
And tan theta equals
Opposite,
Opposite
which
of
is H,
So H
over,
AC.
AC,
and they want you to solve for what?
H. So we can cross multiply and make H the subject of the formula.
Right. So we've already got our tan. Do you see, guys?
Yeah.
So now all we have to find is AC.
Yeah.
And look at
So
AC
we
is the common. So what do you think, Naima? Which of those rules that I taught you guys do you think could apply here?
You see, we have an angle and an included angle that is between two sides.
The
So
cos
I
rule.
think, yeah.
Cos rule.
No, not. Isn't we can't use cos rule because we don't have three sides.
No.
Give you two sides and an included angle, and we have that.
Yeah.
Okay.
So we can
So
use the cos rule.
you can use the cos rule. You could use the thing is the sine rule, but the problem is with the
We
sine
need
rule
two
is that
angles.
you need two angles if you
Yeah.
but you only have
Yeah.
yeah. So the cos rule is much better in this situation. So what's the cos rule formula?
Yeah, that one.
AC is equal to AC is equal to D times CB. D times C
Did you
plus
fill it
CB
out?
minus.
Iman.
AC squared.
Yes.
Let's start from the beginning. AC squared equals
Oh,
D squared.
I was zoomed in. I did not see that. I'm so sorry.
Okay, D squared plus D over 2 squared, right?
D over 2 squared. Y equal to?
Sorry.
Oh,
D squared over 4,
yeah.
Okay.
because we're squaring it.
Minus
2D times D over 2. Then the angle
cos 90
cos
minus
90
A.
minus A.
Cos 90 minus A.
Yep.
Alpha, sorry. You want to do anything to this cos 90 minus alpha?
Change it to sine
Can we
alpha.
reduce it?
Do you see we're getting there?
Oh yeah.
Yeah.
Okay, so
Yeah,
you
so
see,
we
guys,
can reduce it.
it's a process. Okay, so sine alpha. Next, what do we want to solve for?
AC
AC.
squared. I mean, AC,
Right.
sorry, AC.
AC, right? So, but maybe don't you want to make this look nice? Because before you want to square root,
Yeah.
Yeah.
how can you make this look nice?
Can we
Make it look nice. You've got 3
can we
terms.
distribute the negative 2D?
Take out the common factor.
You
Never
could.
mind.
You
Okay.
can, yes, 100%. You can. Why not? Why not, Nafisa?
Okay, now you can.
Minus 2D squared over 2. Isn't that just going to be minus D squared?
Negative.
Minus
Yeah.
D squared. Yeah.
Okay. So minus D squared sine alpha. So it's D squared plus D squared over 4. Do you guys agree?
Mm-hmm.
Now, do we find
Now
the
Nafisa said something. Nafisa made a
Take out the
suggestion.
common factor. Yeah. Then it's 1
1 over 4.
plus 1 over 4 minus sine alpha.
Next.
Yeah.
Next.
Can we solve the inside of the bracket?
Yeah, so 1 plus 1
Not
over
solve,
4.
simplify, not solve.
Sorry,
Let me solve.
simplify.
It's 5
It will
over
be 5 over 4.
5 over 4
Hmm.
sine alpha.
Can we do anything else?
Do we want to?
Remember, we're going to be square rooting. So before
Oh,
you
yeah, we
square
know.
root, you're gonna want to make it look nice inside.
I'll take the D squared inside the bracket.
No, but we took it out.
No, no.
Then what do
Did
we
that?
do?
It just like,
But we
we
just
just
square
did the
now.
reverse.
Can't we make this look nice?
How?
Which one?
Oh.
How do you combine two fractions?
Oh, you make the common
Oh.
denominator, LCD.
What's the common denominator?
4.
4. So it's 5 minus.
Sine.
5 minus 4 sine the alpha over 4.
Oh, then the
Ah,
4's
okay.
can
Yeah,
cancel.
we're almost there.
We're almost there. It's like you're in labor.
Mm.
So next, now we can square root. You see now,
Yeah.
just to make it easier for you to
Yes.
see. Okay, so now we square root. AC equals the square root of that. Now, what did we say early on, Iman? What did you say early on? you taught us something about when you square rooting things which are multiplied together.
Oh, you separate them.
Yes. So what is this gonna be?
So
Square root of d.
D. No, it'll just be D.
Oh, we're writing it like that.
Yeah, and then this whole thing is under the square root.
Yes, but now my question is, isn't the square root of a over, isn't that just the square root of a over the square root of b?
Yeah.
Yeah.
So we can treat them separately.
Oh, okay. Over.
And then
Oh, okay.
Over
Then that one will just
square
be
root
2.
of. Yeah.
Just
but you
2.
told me that h equals ac times tan theta.
AC times. Yeah.
So therefore h is just going to be ac, which is this times tan of theta.
Theta. And we done.
Which is what the question asked of you. You see. Again, I'm going to ask you, did we do any new maths?
No.
No. What changed? Did the concepts change?
No.
No.
The questions changed.
The question changed, but we use the same concepts. So that's why I make the argument that if you know the concepts well and it's strong, then it doesn't matter which question they throw at you, you can answer it because you've got that tool. You see? So that's why I don't want students to get scared when they see questions like this. Students become scared. But what you realize is that for these difficult questions, there will never ever be a memo or a solution that you've not been taught. It's always the same concepts. And that's why you have to know the concepts. So that's why Tutonic spends so much time. I mean, if you obviously haven't done this, but if you count how many hours, like you can see, we've spent a lot of time on this. And we did this for a reason. We did this in the December holidays, 2018, because we knew that for all these questions, sine rule, cos rule, area rule, that's what you guys need to answer these questions. You need the concepts. Can you imagine, how could you have answered this if you didn't know what cos rule is? You guys see that?
Yeah.
How could you have answered this question? Oh, it was still another question after this. How could we have answered this question if we didn't know what, what is cos or tan, and if you didn't know your algebra, you see? Because do you guys agree this was a bit of a difficult one? Well, not difficult, but you had to know your algebra rules. You see? And that's why you learn the algebra rules here, but you apply them here. But that you can't apply what you don't know. I'm not saying you don't know. What I'm saying is that, do you guys see why we designed the algorithm like that? You start with the concepts, then you go to the questions. Do you guys see now?
Yes.
Okay. So now calculate h if, okay, so now they're giving you calculate h, but now they're giving you d and alpha and theta. So you're just subbing in now, right? You see that? Who wants to sub it in for me? Who wants to calculate it?
Okay. I could try.
4 sine of 32 over 2
I think
times tan of
used to be.
63.
I got 499,62.
So kind of like 500. Okay,
Um,
499 9.62. Okay. Yeah.
Elias, for that question, they say D is equal to 300 m. So what do
It's just
we?
Meters,
meters.
meters. Yeah.
Oh, okay. I thought it was like a variable.
Okay, that is a bit unclear. Maybe they should, it's not,
Yeah.
they should, yeah. Okay. We are a bit over time. Are there any other last questions?
No.
You guys feel inspired to go through the concept videos?
Yes. Mm-hmm.
There
I'm
was a
like
student.
I'm done watching most of them. Because like as I go through the sections, I watch the concept videos. So
That's good, and you must do the quiz before you do the past paper.
yeah.
So if you're doing a functions question on the past paper, just do the quick functions quiz, or calculus, do the calculus quiz, just to recap
Mhm.
those concepts. Okay.
You
Okay.
should tell Leila to make more quizzes for us because hers are quite they make you think.
Well, you see that one was functions, and yeah, I mean she did put a lot of effort into it. But we make about 10 quizzes every week.
Yeah.
But I'm going to send those to the matric group because you guys obviously never saw them.
Yeah.
The other
If
thing
there's
is,
other functions ones, please send it to the if there's ones in the hyperbola and the exponential.
yes, no, we've made that. I just didn't send it to you guys because
Yeah.
of time. But you can see if you go. So this is the grade 10 group. You can see. I'm actually gonna maybe make it easier so that you could see all the quizzes for the matric. So here you
Yeah,
can see
please do
hyperbola,
that.
exponential functions, and Leila made all of these hyperbola, exponential. Because the thing is, guys, that quiz that you just did now tests all the concepts that you need to know for parabola, linear functions. So what Leila would do, she would watch the concept video and then set the quiz based on our concept video. And since the concept video covers all the concepts and the quiz is based on the concept video, you're basically testing all the concepts.
Concepts.
The other thing
But I
is
like how we did the quizzes today because it is like fun working with
Yeah,
them.
it was nice.
I'm going to do that next week also because I think you guys to work together. And also because it is a long time ago, grade 10.
Yeah, like we forgot, and then like if the one person remembers and then they explain it to the rest.
Yeah.
It's
No,
fun.
I just tried this out today. I just thought it might help, but I think it's good that you gave good feedback. So I'll definitely.
But I don't think it should take so long to finish the quiz. It is like we spent
But
the
maybe
whole
because we
hour.
did 2 quizzes. Maybe because we did 2 quizzes.
Yeah, I think like instead of doing 2 quizzes, we can do like one.
We can just do one, yeah, because it takes
Yeah.
up too much of time.
Yeah.
Yeah. And the other thing I just wanted to say is that we actually, do you guys see this video I sent to the group? This one. Did you see this one I sent you? Do you watch the videos we send to the group? Do you do the questions we send to the
Yeah.
group?
I didn't watch this one yet.
This video was made by a man named Armin Hendricks. Now, you probably don't know him. I also didn't know him. Armin Hendricks is a retired maths teacher from the Eastern Cape. But more than that, he was the maths subject advisor for the Eastern Cape previously. And he most likely set some of my exams when I was in matric. He sets the exam papers. So it's quite a privilege to have him on the team because when you watch his videos, you will see, because I mean, this is the guy that used to set the exams. He set the NSC exams. So the ones that you guys are going to be writing, he would set papers like that. So when you watch him tutor, he will teach you how the examiners think. You see? Do you see how that's better than just having a tutor?
Yeah.
because this guy, he knows the people who are going to be marking your exams. So he gives you tips. I mean, I learned things watching his videos. So it's a very big privilege to have him teaching you. So if you just watch his video, you'll see how he teaches, and it's nice because he's an examiner. He checks, he moderates the NSC exams. So it's a big privilege to have him working for Tutonic. So and he's a great teacher also, and he's like very old-fashioned, and you'll be like, he'll ask you a question and then you'll make like you've answered, like, yeah, that's right, and then you'll go on. So yeah, so we're very privileged to have him on board. He creates like a video one a day, or once every 2 days. So it's yeah, that's very nice to have him on board. So you guys are very lucky. You see, very lucky to have him. Yeah. Anyway, I think we are over time. It's close to Maghrib. So I'll see you guys next week.
The story time.
No,
Or
wait, your
was that the story?
The story.
What time is it now? Okay, now I'll okay.
No,
So
25, 20 past. Quickly.
okay. So story time. So what if, okay, would you guys say that I know the functions quite well when I teach it to you?
Yeah.
Yes,
Yeah.
definitely.
Of
Okay.
course.
Well, you know
Now,
everything.
what if
well
I
when you-
told you that in grade 9, I got 50% for a maths test?
that I do not believe
That sounds very fake.
I do not believe it.
No, I'm being serious.
No,
So
but
in
just
grade
like
9,
for a test, not like in the reports final.
No,
kind of
that's
thing.
believable for me.
no, I got 50% for a maths test in grade 9, and that test was actually on functions. So the reason why I'm telling you this is because after that test, I was very shocked, very upset, and because of that, I made sure I learned the functions properly as opposed to just memorizing it and not understanding the concepts. So for me, that test was like a wake-up call. So I'm just trying to tell you that it's nothing wrong with getting low marks in school or getting a bad grade, as long as you learn from it. Because I mean, I got 50% for functions in grade 9, and here I am teaching functions to matriculants. So anything is possible, okay? Because the reason why I got 50% was because I never understood things like gradient and equation of linear graph, very simple things that you guys know now. But I'm just trying to illustrate the point how even though I maybe had an analytical brain, because I never understood the concepts, I got 50%. So the moral of the story is that, you know, whatever marks you're getting, just remember that what will save you is your understanding of the concepts. That's where you must start. Always start and make sure you have a strong understanding. And I hope that I've shown you through all the questions that we've done, none of it is new. None of the maths is new. It's just basing and building on concepts and using them in different ways. I hope you guys can appreciate that.
Yeah. It's a
You
really
know?
inspiring story.
Wow,
So-
that was hard actually.
So I want you guys to continue working hard and to believe in yourself. To believe in yourself, because I have, you know, I am very hard on you people. I think sometimes I am a bit too hard, but I can genuinely see a lot of improvement, and that's a good thing. But continue. That's why I say make the mistakes now. Don't make them in the exam. Okay. Struggle now, just, you know, so that you don't have to struggle in the exam. So that's why it's a gradual process, and then you'll see at the end it will pay off for you. You just have to keep on pushing, keep on struggling, because, and I know it's a stressful time for everyone. It's not easy. You're probably getting janaza notices every day, right? About different people. Or is it not as bad in Joburg, Lenasia?
No, it is bad.
But in Cape Town, I mean, you get a janaza notice every day.
Oh,
Like,
I think it was, yeah, because people are not even following the rules and things like that.
oh, okay, yeah. So anyway, I will see you guys next week, and yeah, thanks for coming.
Okay.
Bye.
Okay,
Assalamualaikum.
assalamualaikum.
Oh my god.